Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier from 2024. Question number 9 is on the topic of atomic structure. A student investigated the radiation emitted by two different radioactive sources, A and B. Figure 14 shows a radioactive detector positioned near one of the radioactive sources. So you have the counter detector, which is supported in a clamp stand. Straight ahead is the radioactive source, and you can measure the distance between them. Teacher measured the count rate at different distances for each radioactive source. So the count rate for A is starting lower and it drops to nearly to zero, but not to zero, by about 3 centimeters. Whereas B starts higher and it's actually exponentially decreasing. Explain how figure 15 shows that the source A only emits alpha radiation. Now, source A is emitting alpha radiation because by about after 3 centimeters, radiation levels drops to background radiation. That's why it's not going to zero. B is transmitting probably gamma because its range is much bigger, or it could be beta as well. So, answer. Radiation from source A travels approximately 3 centimeters in air, after which count rate decreases to background radiation because alpha radiation has a short range in air. Figure 15 cannot be used to determine if source B emits beta radiation or gamma radiation. Explain how an absorbing material could be used to show which type of radiation is emitted by source B. Now, if you place an thin aluminium sheet in between the source and the detector, then if the radiation level drops to zero, that means it is giving out beta. If not, then it's giving out alpha as well. Gamma. Use an aluminium sheet which beta radiation will not penetrate, but gamma will penetrate. The teacher took safety precautions during the experiment. Suggest one safety precaution the teacher would have taken to reduce the radiation dose the teacher received. There's a number of things that you can do. You can pick from this list. Increase distance between the source and the teacher, or limit the exposure time. Use tongs or forceps. Wear a lead apron. Keep source in box unless in use. Stand behind a safety screen so that you don't get alpha or beta. Point the source away from the teacher. Suggest one safety precaution that the teacher would have taken to avoid being contaminated, so that they don't get it on themselves, on their body or their clothes. You could wear gloves, wear an apron or a lab coat, or handle the source with tongs and forceps. Figure 16 shows how the number of atoms in a radioactive element in a sample varied with time. So 6 times 10 to the power 23 atoms it starts off, and it's decaying exponentially in seconds. Activity is the rate at which a source of unstable nuclei decays. Determine the activity of the radioactive sample at 300 seconds. Give the unit. So you could draw a straight line from 300 at this point, and then work that out to be 2.8 times 10 to the power 23, and you would get just 1 mark. Well, probably not that, because here you have to draw a tangent. So let me attempt to draw a tangent. Tangent is a straight line passing through that point. So let me see if I can draw a straight line. So it's about positioning this line slightly. right? Now measure from there all the way down. This is 0.8, that's 4.6. So 4.6 minus 0.8, 16, 3.8 is equal to y. X is, that's 50, and this is 570. So 570 minus 50 is equal to 520. So gradient equals y over x. Y was 3.8 divided by 520. Maybe do that in my calculator. So the important thing here is for you to actually attempt it by drawing a tangent. So based on the way you are drawing, the answer can actually be different. Now in the marking scheme, they give you a specific answer, but they also say 1 mark for drawing a tangent on line at 300 seconds, and then the second mark to attempt to calculate the gradient of the tangent, and there's a mark for the unit as well. So let's do this calculation. 3.8 divided by 520 is going to be 0.0073 times 10 to the power 20. Is it 23? Sorry. Times 23. Now, the reason I'm writing times 10 to the power 23 is because the y-axis, actually, the number of atoms is 10 to the power 23. I didn't write times 10 to the power 23, and I wrote 3.8. So this number can be written as 7.3 times 10 to the power 20. 7.3 times 10 to the power 20. The marking scheme actually says 7.1 times 10 to the power 20, but this is also fine. It's in the range, within the range. The unit is becquerels, which is BQ. That brings us to the end of this question number 9, and I will see you in the last question number 10.